It's going to be on the updates of the 3 design guides that we have been working on, where Professor Ghali has, of course, significant, contribution to all of them. So we have been actually working on 3 of them parallel. So a lot of work has been done by the committee members, the task group in particular, and Professor Ghali in particular in the task group. It's him and Dr. Guide actually who has been leading the efforts in most of the updates. I have been serving as the task group chair for the 3 different design guides. So I will go over the major updates in 3 of them, since there has been work on 3 of them parallel during the last 2 years, maybe more than that actually. We have, so the paper on this is going to cover the major updates and the conflicting provisions between, if this is the right term, but between ACI 421 documents and ACI 318. Not necessarily conflicting, but there are some differences that we will highlight and that are very important. So ACI 421.1R, which is a guide for the shear reinforcement for slabs. So this, the latest edition has been published in January 2020. The one before that was in 2008. So there have been major updates to this one, mainly the code updates to 3.13.14. There have been general updates. There have been some editorial updates, and there has been chapter 7 that showed the major updates compared to the other chapters. And of course, all the references has been updated to most recent references that are, of course, reflect the state of the art in this field. Some of the updates were related were in the definition section, where some of the definition sections, some of the definitions were removed. So this is what we have right now that covers the headed shear stud reinforcement, the shear caps, shear critical sections, and slab moment resisted by supporting column. This is what we had before. So some definitions were dropped and actually defined within the document, but not in the definition section. So this is part of the editorial revisions that were done. In the scope, there was a revision that was related that actually was related to covering what's in the 3 different design guides for ACI 4321. So it was added that the design of flexion and shear reinforcement in slabs in ACI 421.1R and 0.3R consider forces specified in codes, including effects of gravity, winds, and earthquakes. But ACI 421.2R addresses seismic design of shear reinforcement in slabs. So just to clarify what is the intent of each of the design guides, because there are some some overlaps in some of the provisions, but not many. There were some major provisions to chapter 7 that moment transfer at slab column connections. So some of the notations have been changed, some of the equations have been changed. Things related to the shear stress due to moment transfer, MSC, and the reduction factor of gamma sub V, anchorage of shear reinforcement, layout of shear reinforcement, and minimum shear reinforcement. So the major update was in this chapter. And the references, the listed some of the references that, of course, were based on most recent research. Remember, the previous edition was 2008. So we have, it shows the papers that were published up to 2017 in this guide. And 421.2R, so this guide, that's guide to seismic design of punching shear reinforcement in flat plates. This has been ballot. This went through several ballots and has been submitted to TAC. And after addressing all their comments, so we're hoping this will be published soon. Maybe not 2020, but could be 2021. And this also covered the general updates, editorial updates, and also updates from 318.08 to 318.14. And then there's chapter 6 also as major updates, and also references that were adapted that were published after 2008. Now, one thing that was modified in the scope of this document is related to flexure-induced punching shear, which you heard a lot about today, which is also based on a paper by Guide and Gal in 2019, and of course other research done performed by other researchers. And the objectives also were modified, that was related to the minimum requirements of shear reinforcement, in addition to those in ACI 421.1R, which was published, needed for ductility. The role of shear reinforcement in connections subjected to moment reversals induced by earthquakes is to ensure no collapse until yield line mechanism develops in the vicinity of the support. Development of yield line mechanism is considered an evidence of ductility as defined in section 2.2. So again, this was added to the objective, and again to highlight the requirements of that are presented in each section, and also to highlight the yield line mechanism, which is also related to the induced flexure-induced punching shear. Some of the definition has been added also in this that were not presented before or were modified, such as flexure punching, shear critical sections, lateral force resisting systems. Those was with some modifications, and the probable flexural strength that was added to be consistent with ACI 318 and other documents. In chapter 6, section 6.3, that was titled upper limit for M sub U, has been changed to probable flexural strength, and there have been also modifications to this section. Section 7.4, actually this is an important section that was added to this, which actually highlights some of the differences between this document with other ACI documents as related to slab column connections. So the section actually provided clear provisions, and which of course also justified with ACI 318 procedure, but are different from other ACI documents. Again, here, as you can see, some of the references in 2017, 2018 that were added to this document to reflect the most recent research on this. And ACI 421.3R, this actually was published in 2015, and we have been going through the updates of this one. We had the first ballot on it. So the current provision reflects the changes from 318 to 14 to 318.19. Some editorial changes, some changes to the appendices, the analysis methods, and the deflection analysis also, as we'll talk about. So appendices, we had two appendices that talk about the direct design method and the equivalent frame method. Those are proposed to be removed. So far we don't know if this is going to happen or not. finite element analysis. So we had chapter 3 in this guide covers the different analysis method for two-way slab systems. So in the previous edition that was published in 2015, we had a brief description of each analysis method. Now this analysis method has been expanded in more detail. So this section covers linear finite element analysis, modeling of slabs, verification of results, application of results, nonlinear finite element analysis, and calculation of shear strength of slabs. And then the yield line theory also, we had a very short section on that. This has been expanded as well to cover general considerations and determining the yield line patterns and analysis with the yield line theory, design applications, and limitations and advantages of the yield line theory, and the strip method, that this has been actually expanded significantly and covers the general considerations, strip method for design, advanced strip method for concentrated loads and supports, and limitations and advantages of strip method. And grid analysis. This has been also expanded significantly. Degrees of freedom and internal forces, grid with 3 and 5 displacements per node, member and forces, and representation of gravity loads and pre-stressing forces, displacement boundary conditions, and section 4.10, which is new, flexure-induced punching. And so this is one of the main additions to this guide, actually, in addition to the expansion of the analysis method. So minimum flexure reinforcement required for a given factored shearing force, simplified design, and thick considerations for thick slabs. Another major change in this guide is deflection analysis. So in the previous guide that was published in 2015 gave a general introduction and then talked about simplified methods, for deflection analysis. Now this goes in detail and with design examples, and which covers also what Professor Ghali covered today in his first presentation in part 1 of 2 of this symposium. So this covers creep of anchorage and the relaxation of pre-stressed concrete, immediate strain plus, time-dependent strain, cross-sectional properties, deflection curvature relationships, daily temperature variations, twisting moments, and steps of analysis to calculate immediate and long-term deflections. Example, slab with varying post-tensioning, and simplified analysis, which is according to ACI 318. So there is a major contribution to in this section. So with this, I conclude, and I thank you all for being in the 2 sessions today, honoring Professor Ghali for his contribution to our profession and to the concrete industry. And I would like also conclude by congratulating him on this symposium and on his contribution throughout his career to the profession. With this, I thank you all.